Well, hello. We are at Module 5 of
Already.
the Database Fundamentals course on MicrosoftVirtualAcademy.com. Wow. So if you've been with us for the first 4 modules already, we started back with core concepts of what a database is and why they're important. We went on from there to a second module that was about
Normalization.
normalization
All that conceptual
and
stuff that you have to
referential
walk
integrity,
through.
kind of a little bit of design fundamentals.
Yeah.
Then in Module 3 we did how we actually create databases and the objects that live inside of them. And then we just got out of Module 4 where we learned all kinds of things about using data manipulation language to get data out. And then we talked about insert, update, and delete to manipulate the data that's in a database, which is a lot of information to cover in just these 4 modules. But in Module 5, we're going to just wrap the course with a little bit of information about how to do basic administration. And this is very specific to SQL Server, which we've been using as the example database management system for the course. And you're going to help us understand kind of a little bit of security fundamentals and some data management backing up and restore type functionality for keeping our database administered nicely.
Nicely. Yeah, that's a good way to put it. Exactly what we're going to do is, one of the things that we've talked about is how much data we can store inside a SQL Server, how we want to design that data, and how to add the data and retrieve the data. But now we need to protect that data. So we're going to look at how SQL Server implements a security infrastructure. And the other piece that we're going to look at in this module is making sure that that database, the data is backed up regularly. In the event that something happens, you need to recover that data. So we're going to give it the basics on doing backups and restores. So securing the data and then backing up and restoring that data in the event that you need to do so. So we're going to talk about that in this module. We're going to begin with SQL Server Security. Really, when you look at that, there's 3 components of security. We have what are called securables, which is the server, the database, and any object, the stored procedures, and the tables and the views that we looked at. We also use the term principals. The principals are the individuals or the groups, whether they be Windows groups or individuals logging into SQL Server that are granted access to SQL Server. And then the last piece are permissions. What type of permissions are we going to give someone to access the content stored in a table or stored in a view? So it's the securables, the principals, and the permissions. And this graphic here shows you kind of a high level of how that works. You've got the principals over on the left-hand side, and you have Windows level security, because you can have 2 types of security. You can have Windows authentication, or you can have what's called mixed mode, which is a combination of Windows authentication and SQL Server logons. So at the Windows level, we can actually use a Windows group, a domain login, or a local login. At the SQL Server level, we have fixed or user-defined server roles. We'll introduce those. We have a SQL Server login. So first off, you have to log into SQL Server before you can access the database, before you can access objects in the database. So it's kind of a 3-tiered approach that we're using here. At the database level, we have fixed database roles. Not server roles anymore, but database roles. We also have user-defined database roles that we can create. We're going to talk to those. And then once you get inside of the database, you've got these items, tables, views, functions, procedures, different information that we want to protect. So to me, I always like to introduce this as a 3-tiered approach. Give the individuals access to SQL Server. Give them access to the databases, because they don't need to get access to every database. Give them access to the databases that require access that contain objects they require access to. And then give them access to the particular objects. And I can give them different types of access. I can give them just the ability to query information from a table, or to be able to update information in a table, as an example. So the 3 tiers are accessing SQL, accessing the database, and accessing the objects within those databases. And we talked about the different terms available for us, the permissions, the securables, and the principals for doing so. Here's our 3-tier approach. We need to log in. It could be a SQL Server login, or it could be a pass-through login using Windows authentication to get access to SQL Server. We then need to give you a user account in the database that you need access to. And lastly, we need to apply permissions to the user account, which, oh, by the way, is mapped to the login. That's at the SQL Server level. So we have our SQL Server login. We can map a database user to that login in every database that you need access to. And then we decide within that database what permissions that you are going to get access, or what objects you're going to get access to, and what permissions you have with those with that object. We have a couple different types of authentication. We have Windows authentication or pass-through authentication. So it takes your credentials that you use when you're logged into the domain, and it uses those to authenticate you and give you permissions to log into SQL Server. We also have a group. You could be in a Windows security group. And that security group, if you're a member of that security group, if that security group has been granted permissions, you're going to have access for that. And so that's Windows authentication. We have what's called mixed mode, which is a combination of Windows and SQL logins. So if you don't have a Windows authentication, a way to log in, we can create a login for you inside of SQL Server. This is great for individuals like vendors that are external to the organization that don't get authenticated by an Active Directory environment or a Windows environment, so we have to give them a SQL login. And what we can do with these logins is we use these logins to map them to either the server roles, fixed or user-defined, or the database roles, fixed or user-defined. And that's what's going to decide what permissions you get inside the database that you get access to. Now, by default, SQL Server provides several different fixed server roles to define. A few of the key ones are sysadmin. You get full party rights to do whatever you want. You can uninstall SQL Server. So you've got to be really, really careful about giving that one out. The DB Creator allows you to manage databases. So I can create a database and manage that entire database. That's another fixed server role. Security Admin allows you to manage who gets access to SQL Server, who gets access to the logins, can manage the logins. So these three, just three of several that are out there, are available to you out of the box. SQL Server 2012 introduces user-defined server roles. These roles may not meet your needs for what you want your users to do. So you can actually create user-defined server roles that have special permissions depending on what you want the users to be able to perform once they connect to SQL Server. What you do is when you create the login, you identify what roles you want the individuals to be in, and that's going to determine what permissions they get. So you have your fixed database roles, your fixed server roles, and then you also have your fixed database roles. And within that, that's where we start talking about, so we've talked a little bit about connecting to SQL Server using a login from Windows or SQL, but we also have to look at securing SQL Server databases and the objects within those databases. And as I've just briefly mentioned, once we get access to Tier 1, which is the SQL Server level, Tier 2 is access to the database level, or whatever principal you want them to be able to access. I can map any of my logins, whether it be a SQL login or a Windows login, to different databases, depending on what they need access to. Once I give them access to the database, I can define what roles, whether they be user-defined or fixed database roles. I can define which roles I want them to be able to apply to. And there's a special role that's out there. People always see it, so I want to bring it up. If you happen to manage permissions, there's a special role called public. You can't delete it, you can't modify it, you can't move people in and out of it. It's just there. And so what happens if I happen to attach or try to connect to a database, it automatically, once I get permissions to that, it automatically allows me, populates me into that public role. So no management. It's actually used if you want to connect to a database, and let's say you want to print something. It kind of gives you some of the default permissions you would have or want inside of a SQL Server. The fixed database roles, just a few of these to mention. These are the fixed ones. DB owner, which means within that database. Remember, we had DB creator. That was at the fixed, at the server level. They can do anything they want. They have full party rights. DB owner has full party rights for that one database. So if I'm DB owner for sales database and Pete's DB owner for the Adventure Works database, I can't do anything in his database. He can't do anything in my database unless he gives me permission. So you're DB owner for a specific database or specific databases that you have permissions to. Another popular role for the fixed database roles is a DB data reader. So anyone who's in that role can read any data inside that database. So it's kind of like granting read access to everything in the database. And another one is DB data writer for individuals who actually want to be able to perform those inserts and updates and deletes that we walked through in the previous module. So those are available to us as a few of the fixed database roles. Similar to fixed server roles, we can create user-defined database roles. It is highly recommended for us to create fixed or user-defined server roles and user-defined database roles because it gives us a more granular, a way to provide more granular permissions to our users. We have more control over what our users are getting for permissions if we use our user-defined roles versus the out-of-the-box fixed database roles or server roles. So either way, however you decide to do it, use these roles, whether it be the user-defined or fixed roles, to provide permissions to the users inside of SQL Server. Let's just jump out real briefly here, and we're going to jump back into our SQL management here. And so remember that first tier I said we need to get into security. So we've been talking about databases primarily. In here under security, we have a thing called logins. The logins is where you want to be able to map our users to give them access to SQL Server. It's pretty straightforward. Of course, there's transact SQL statements for this, but we're going to do the Windows way because we don't get paid by the hour. So we're going to go create a new login called Contoso Linda, and then we're going to go at default database they're going to map to. Get my mouse back. Disappeared on me. I don't know what screen it's on. Is it on yours over there? Oh, here it is. Really, I do have a mouse in here. There it is. Okay. So I'm going to say they map, when this person logs in, Linda logs in, she maps to AdventureWorks 2012. I can actually go up to the fixed server roles. These are the ones that I introduced to you already. I'm going to trust that she can take care of security, so I'm going to make her part of security admin here. All right. Now, I could also go into the user mappings here at this point. And here, I'm going to say I'm going to give her access, because although I said I want her default database to be AdventureWorks, I've not even given her access to do that yet. So what I need to do is check this box and say for AdventureWorks, Linda has permissions to access. That's that second tier that we're providing. And then I'm going to make her DB owner. It picked up the fact that she had security admin. By default, it added DB owner for a fixed database role. I could change that to just be a DB data reader if I wanted to. So when you create the login, which is mapping your Windows, in this case here, mapping your Windows authentication login to SQL Server, it provides you the capability to also at that point decide what databases she's going to get access to. I can even go down to securables here, and here I can actually search inside databases and assign permissions at this point. I'm going to do that a little bit separately. I just wanted to show you at this point here what I can do is, first off, map her account, her Windows account to SQL Server, gives her that first tier access. Secondly, and assign what server role permissions she gets. Thirdly, assign what database she gets access to. So I can go ahead and do that, and I'll just go ahead and click OK on that. And I'm going to get that failed. Now column's name is missing or entered for select into statements. Let's see here. So maybe, I probably need to do this. Let me try that one. No, great, failed for login. So we're going to already exist. Okay, so let's see if that's true. Let me go over to AdventureWorks. The users are stored over under security over here. Users, oh, she is already there. All right, so we're going to toast that right here. We're going to delete it. And okay. All right, now let's go back and try that again. So it was yelling because I was trying to add her to AdventureWorks as a user, and she was already in there as a user. So let's go back to our login box, see if it'll quit yelling at me. Try another OK. Still thinks it's there. Let me do a quick refresh. Refresh usually helps with this. Okay, I don't want to create a diagram, I promise. Let me refresh this. Let me go check security and users, not to be found anymore. All right, let me try one more time here. See if it'll add her this time here. If not, I'm going to switch to a different database if it yells this time. All right. So what I'm going to do is I'm going to give her access to our class demo database instead, being it still thinks she has access to that. Let me check everything I've done here. I'm going to go back up to general, Contoso Linda, server roles, security admin, user mapping. We'll give her access to class demo, and we'll just go ahead and click OK. Principal will already exist. All right, so maybe it's up even further. Maybe let's go back to here. Refresh. All right, let me delete it from here. All right, let me try this one more time. It seemed to see her in security logins already. So let's try this one more time here. So let's check again. Contoso Linda, server roles, security admin, class demo. Okay, that time it worked. For some reason, it still had her in logins. Let me just refresh. Okay, she shows up there, and then we go to the class demo database that we created. We'll go into security there, and you'll see under users that she has access to there now. So using a quick, pretty easy and straightforward the interface where I can create an account, Windows account, map it to SQL Server, give her access to whatever server roles, whatever she's going to be able to do at the server level, which was security permissions, and then give her access to databases in whatever database and whatever permissions she'll have within those databases.
So we should just talk about what just happened
Sure.
in context of the rest of the course that we've been through. When we started out really simply with the CD library example, that might just be a single-use database. When we got up to something like Adventure, and in that case, you wouldn't necessarily need elaborate administration.
Right.
If you were in Access, you might grant it to one other user, but you might want to lock it down so that lots of people didn't have access to your library. In the case of the AdventureWorks, it's an enterprise class database with all kinds of different tables in there to manage different parts of the application. In that case, you want to think about the security model and the administration of the security to provide sort of the least privilege for the users so that people can't go get to any of the data that they may not have the business access to see. And that's kind of what's happening here with respect to the securities. You're thinking about the business use of the data, you're thinking about the users that are going to get into that data, and you're trying to create a security model that provides that sort of business rule for who can get into the data.
That's exactly right. So yeah, just to the event that you want to protect that data, you've got ways to protect that data. Like you said, if we're just worried about our albums, may not be too worried about that. But this is just more of a heads up as to what you're going to be, or you would be concerned about if this was in a bigger environment. That's exactly what we're doing. There's a guest account that's created in every database. How this is used is, if let's say I want to give everyone access to this database, it's going to be read-only database. I want to give everyone access to that. I can do that by just enabling the guest, giving them access to SQL Server, and they have access to the database, to SQL Server. If I haven't specifically given them access to the database, it will allow them to come in as a guest. Now, by default, guest doesn't have anything for permissions, so you have to assign permissions to that guest account. It's enabled by default. You can disable it if you want to disable it using this command here, revoke connect from guest, and that will prevent people from being added into that. So if you're in a real high secure environment where you don't want anybody seeing anything unless you give them specific permissions, you want to be careful about that guest account because it is enabled by default and is available for use by default. If someone happens to create a login, didn't deny them permissions to a database, they do by default have permissions to whatever the guest account has in there. So they can at least connect to it and be able to establish that connection. Now we manage the permissions. It's supposed to be 2 lines, 3 lines here. We manage the permissions using 3 commands. And these commands here are grant. So I want to grant the select permission on a particular table to Pete. So I would do grant select on table XYZ to Pete. And then I could do revoke. So my revoke is going to reverse the last permission that I provided to an individual. The reason I'm saying that, why I jumped down to revoke and over deny, is because I could do an explicit deny to Pete on a particular table. And how I take that deny away is to revoke it. So it's going to always, the revoke is always going to reverse the last permission that you applied, either a grant or a deny. Now, why would I use a deny? A deny is available if I want to explicitly say that I don't want Pete in looking at this content. Now, Pete can come in through an individual account. He can log into SQL Server that way. But Pete's also a part of 5 Windows groups as well. If I do an explicit deny, it doesn't matter if he's part of 500 Windows groups. I've explicitly said, do not let this person into this database or look at this object. So you grant permissions, you apply permissions using grant, you revoke them. I put them with what I call in neutral mode. I haven't said you can touch it, but I haven't said you can't touch it by using deny. So you grant and then you revoke, or you deny and then you revoke. So you reuse these terms or these statements to manage our permissions in SQL Server, specifically at the object level. Now, what I can apply for permissions, I can grant select for Pete, so he can come in and view content. I could grant select and insert, so you can view content and add content. I could grant select and delete. He can grant and delete content. So I can be very granular as to what permissions the individual or the group can have on a particular object inside of SQL Server. And we're talking about the DRI, data referential integrity. That's the reference when we use that for the foreign key back to the primary key we talked about earlier. And the execute is for executing store procedures. And that's a short term for that is EXEC instead. So those are different types of permissions that we can apply to tables or stored procedures or views. Depending on the type of object, we'll determine the type of permission that we apply to those objects. But they're managed using the grant, the deny, and the revoke. Is that enough, you think, to
I think that's great.
explain?
And this is another, we've said this several times during the course, this is another opportunity for a lot more further study. We have an entire course just on database administration that goes in depth on sort of the theory for database security, as well as all of the implementation details for how you set it up.
Yeah, I think the thing we wanted to do is just make sure you're comfortable with the idea that, you know, we're not just because you created these database and tables, you do have to be aware of the fact we can lock these down, we can secure them. Not worried about it if it's just our artist collection, but if we're in a more of an enterprise level or bigger environment where we are concerned about security, there are ways using what I call a three-tiered approach to SQL, to the database, to the objects, that we can control what your users get access to. So just a more of a high-level overview. Now, one of the other things that we have to be concerned with is protecting our data, because as if you are a DBA or aspiring to be a DBA, one of the probably the biggest things that you're responsible for is protecting the data and making sure it's available in the event you have a power failure, you lose a disk drive, any possible situation where you might lose data. So what we're going to just do is briefly introduce, just so you have an idea, because often we get questions like, okay, Brian, I'm going to put all this data in there, and I'm going to store it in there, but what happens if I lose that data? Okay, like what happens if I lose my Excel spreadsheet? Well, we have backup and restore capabilities inside of a SQL Server. We're going to use the GUI to keep it simple, but we can write scripts. We can script this all out, so that way we can run these at night. And the advantage of writing scripts. So the GUI I'm about to show you, again, if you get paid by the hour, you can set the alarm at 2 o'clock. You go up at 2 o'clock in the morning, you log in, and you perform a backup using the graphical user interface in SSMS. But if you don't get paid by the hour, you can write a script that performs the same task I'm about to perform and trigger it to kick off at a certain time, so it's running while you're sleeping or just getting home, depending on what you're doing in your nightlife. So let's go take a look at the database backup. It's actually performed in the event that you need to restore that content. Somebody may accidentally delete some content, or we may accidentally, a hard drive may crash, and the content that I was on that hard drive gets lost. We need to be able to recover that content. So what we can do is use a database backup that will allow us to restore that content. Now we can only restore it depending on and we won't even get close to being able to explain all this, but we can only restore the content as good as the last backup. So if you do backups once a week and it's on Sunday night and you do have a system crash or you lose a hard drive on Friday, you've lost a week's worth of data. So there's a whole strategy in place on how many backups and how often and the different types of backups that you need to be aware of. And there's really just 3 key backups that can come up with a decent strategy for you. Those are full backup, where you back up everything regardless if it's changed. We could do a full backup every night if we wanted to. If I got 30 gigs of content, and if I do a full backup every night and it takes 3 hours, when only 10% of that content changed, maybe I don't want to do a full backup. Maybe I want to do a differential backup. Differential backup, I also call it a cumulative backup. It backs up the content that changed. So again, we did a full backup on Sunday. It backs up all the changes from Monday. I do a differential on Tuesday. It backs up the changes from Monday and from Tuesday. I do a differential on Wednesday. It's cumulative, that's why I'm saying that. Monday, Tuesday, and Wednesday are all backed up. The reason that we like doing differential backups is because when you get ready to restore content, we want to minimize the downtime. If I have one full database backup that I have to restore and one differential backup that I have to restore, it's going to shorten the time it takes me to recover, and that's going to be a good thing. So differential backup is a cumulative backup that keeps track of all the changes since the last time that we did a full backup. An incremental backup is also a transaction log. Those are used synonymously. So an incremental / transaction log backup. Let's go back to our scenario. Sunday night we did a full backup. Monday we did a transaction log backup, not a differential. Tuesday we did a transaction log backup. Wednesday we did a transaction log backup. Now if I lose content on Thursday, what do I have to do? I have to restore the full backup from Sunday, the transaction log from Monday, then the transaction log from Tuesday, then the transaction log from Wednesday. Could take me a lot longer to perform the restores of those transaction logs. So differentials are helpful. Some people do full backups, we'll say once a week. Differentials every night. Incrementals or transaction logs every hour during the day. Your strategy will depend. The bottom line is you always have to answer the question, how much data can you afford to lose? If the answer is none, you need to be very particular about what type of backups that you perform so you can recover that content in the event that you need to. just to let you know, these are the 3 primary backup types that you need to be familiar with. There are others that we're not going to get into detail. So if you're looking around at this, because you're going to be excited about SQL Server when we finish today, if you're looking around at this, there are other types of backups that you can perform. Take a peek at those, but these are the 3 primary ones that you'll be using here. So let's go ahead and back up a database just to show you how easy it is to do this, because we're going to use the GUI. And back in the SQL Management Studio, let's back up. Let me see. Let's in class demo. Class demo, nothing. Let's go. I thought we created a table in there. Did we not over there? Well, we created that one in sales. Let's go and create. Let's do this. Let's do a new table in class demo. Thought I clicked that. So I showed you how to create a table using Transact SQL. You can also create a table inside the GUI. It will happen. So we're going to call this column 1, real definitive as to what it is. Here's my data type. The default is nchar10, and we allow no's.
I thought for sure you were going to start creating the CD library database.
Artist. We'll do the artist.
You're going to do the artist table. Interesting.
Yeah, we'll do the artist one, yeah. I know I didn't want to get over to, I keep losing my mouse. I didn't want to get over to the disco one, you know, the genre. So artist, what we had? Well, we would have artist ID, actually.
Artist ID and probably artist name. Maybe.
Yeah, artist name would be good.
Probably a picture.
No, artist name, I need to, notice I'm going to use that Pascal.
Birthday.
Birthday.
I'm going to keep giving you columns until you stop. So
All right,
you do as many as you want.
Let's change this, because now we found out these guys can be crazy with names. We need to bring this back to an int for artist ID.
Because that'll be your key. Look at us sort of reviewing everything we just did today.
Yeah, this is going to be our int there. And we're not going to allow nulls. And let's do one more here.
Birthday, maybe?
Birthday. Because
I'm sure that you and Donna Summer have the same birthday.
Yeah. Well, we went to different schools together, so. And once that'll give us a chance to use. I just have no idea why my mouse just disappears every once in a while. As soon as I get my mouse, oh, there it is. It just disappears.
It's jumping out of the VM. That's all right.
And we're going to go date.
But this is cool. This is a 3rd data type in this table.
Yeah, so we have an int,
awesome.
and varchar, and a date. The bad thing is we're going to toast it anyways. Well, not really, but. All right, so we have a new table here. So we're going to save this table out. And we're going to call this artist. And I think we should have done a genre so I could just type the word disco in. I mean, we talked about it all week, all day. All right, so we have a new table. So we'll come over here to our tables. We'll refresh it. We see our new table here. All right. Now, the reason I did that is because I'm going to back this up. I'm going to go to Tasks, and I'm going to use the backup option. And it's going to back up class demo. And by default, it dumps it way down here. And, you know, we're going to get rid of that. I've got another easier directory to remember to chase it down afterwards. And we're going to back this up to, it's always, no, I won't even say it. I was going to make a joke, but if someone really doesn't understand, they might think I'm serious. And I'm like, no, I'll leave it alone. We're going to back up to SQL backups. And we're going to call this class demo DB. It'll use the .bak extension, so I'll just let that go. I'll let that go. There it comes back. So we're going to back it up to there, and we'll go ahead and do an OK. And then we'll click off on OK on this one. And the backup database class demo completed successfully. All right, cool. So that's done, and we know in there that we should have the dbo.artist. Now, there's a slide on restore, so I'm going to just stay in the demo, but let's pretend that somehow this dbo artist gets toasted.
You've been waiting to toast something for the entire class.
So I know.
I think you should do that.
I know. I should have actually. What I should have done is prepare and written that stored procedure called toast.
Procedure called toast.
Yeah,
exactly.
I'm going to work on that.
Actually,
I had it
the
once.
T-SQL command for drop.
Yeah, I'm going to definitely write that. So I'm going to delete this. Now, this could be somebody accidentally deletes it, or they run that delete command I told you about without a where clause or an update. Maybe just the data is bad because someone ran an update without a where clause. And the faster way to get it back is to go do a backup. So I'm going to go ahead and toast this. And I'm going to do a refresh over here in class demo. You'll see under tables now, the table's gone.
Gone.
All right, toast. All right, so how do we cover it? Class demo, go back to task, and we have the restore option. And database, and we're just going to keep this the simple method. It knows what's been backed up. It's telling me right now, the only thing I have for you is a full backup. If there were differentials and incrementals, it would list them all out. It would make sure I restored in proper order. It wouldn't let me jump around and stuff because that'd be badness. So it knows we backed it up. Here's the date and the time for the backup, so we know it's good. And let's see here. I'm just going to leave it just at this, like this. Attempt to restore. And during the restore here, it's actually what it's doing. It's actually looking at the information that's in the backup and determining exactly where that needs to go to do that restore. And looks like it's okay. Well, how can we test? We'll go back, see if our table's there. Let's do a refresh, because it's not showing up. Still not showing up. Sometimes the refresh has to go all the way to the top here. Let me do that one. Let's see, what am I doing this guy here? Still not there. All right, let's try another restore, because that didn't seem to pick it up. So I did the backup. I toasted it. So it should be there. All right, let me try it one more time. All right, tasks, restore. Database. You know what? It didn't come back up and say it was restored. It should come up and say it was restored. And I didn't see that pop-up box. So let me try this again. So we've got this check.
But the backup is still on disk, so it should be totally fine.
Right, correct.
Because it's listed right there.
This ends right here. It should say restore completed successfully. And I didn't see that last time. And it really shouldn't take that long because there's really no data in there.
I still think this might be a ploy, so you can create the genres table.
Yeah, really. I really want to type in disk out. No, see, it's not. It's
restore
database failed. All right, let's try this. Let's do the verify backup just real quick. So that's okay. All right, let me cancel this. Let me try one more time. Tasks. Restore, database, and class demo DB is the database there, database, full backup we just did. Let's see if there's any options. I'm not trying to move it.
Is this similar? Is there somebody connected to it? Is that problem?
It may be. Let me try this. Closing existing internet. This mainly does a single user. Let's try that, just in case it is. Because it should be a nice right there. That's what it was. Because I was still connected to it.
You were still connected to it.
Yeah.
I thought we were going to have to do some tap dancing or something to entertain the audience while that was happening.
Yeah, seriously. Let's see if it worked though. Let's go make sure it's over here. Yeah, there we go.
Got it.
Yeah, I was still connected to it. You're right. So it didn't get exclusive. It needed to be in single user mode. So I did that on purpose. So you guys can see it's not all peaches and cream to try to do a restore. There can be issues, even though it looks pretty straightforward. There's little things like connections that are out there already established. You need to make sure brings it during the restore, it brings it into certain modes so it can actually has exclusive rights to be able to do recovery.
Which is why there's a whole course that has like 3 modules on backup and restore strategy and implementation.
Yeah, disaster recovery, and I mentioned the term earlier about RPEs, resume producing events. DR is going to be the most likely reason you have to generate a new resume because just not enough, the backups weren't done or people were performing a backup and they didn't realize the backup wasn't working.
Which is actually pretty cool because we've gone from the very beginning of the day, we went from a spreadsheet, which you can have a backup strategy for. You can copy it to multiple locations. You can do cloud backup for a single file and things like that. We've gone all the way to, I need to take a class and just how to do like a strategy for creating incremental transactional backups for my enterprise class database.
Yeah. I mean, the backups is a class on backups, a class on data modeling or designing your database would be another one. Once you get the database design out there, what's the best way? What kind of queries can I perform? How can I add content, update content to it? So all sorts of options that we've been through today and a high-level overview, but it's the real world for what it needs to happen. So we did so very similar to backups. We had the differential restore. We would perform those in order, and once we did those in order, that would make it easier for us to get that complete database backup, get the differential backup, and then get the transaction log backup restored. And I already did the restore because I was already out there. So, objects that we need to secure, 3-tier approach. Giving them access to SQL Server, whether it be through Windows authentication or a SQL login if it's someone external to the SQL world. We introduced the 3 terms of secure roles, principals, and permissions. The second area was giving them permissions to the databases. We saw that. We can do that as we create the login. And the third one was giving them permissions to the objects using the grant, revoke, and deny permissions to manage those permissions. So login, database user, and then permissions to the objects are the ways that we're going to control our information or security permissions to our information. And with that said, Pete, I think, like you said, we started out with a basic old spreadsheet this morning, and now we've gone through like how we can create a relational database with tables and enforce referential integrity by using primary key constraints and foreign key constraints. And we talked about how we can protect the data by implementing security, how we can use select statements for retrieving the content, and slicing and dicing it several different ways for adding content, deleting content, and updating content. And then we wrapped up by talking about ways for securing that content and protecting that content by performing backups and restores. Is there anything you'd like to add?
I think we've nailed it. I think we covered everything we wanted.
And we still don't know what disco albums you had, so I'll find that out.
A mystery.
It will remain a mystery.
Follow me on Twitter and ask.
We did learn though that there was it 360 character title name out there, so that was going to totally redesign.
360 word.
No, it's 89 words, 360 characters.
89
yeah,
words, 360 characters.
So that totally redesigns our plan
so
for.
know your data. I think it's the lesson.
Exactly. Know your data.
Yeah.
Thanks very much, folks.
Thanks for watching.
Thank you.